Hello friends, in this video we are going to deal with the remaining conceptual ideas from straight lines. Already in the first part we learnt about the first four conceptual ideas from straight lines regarding mains examination, and now the fourth conceptual idea. See, the fourth conceptual idea is related to the area of the triangle along formed with the by the straight line with the coordinate axis. See, for example, this is the x-axis whereas this is y-axis, and we have a line in the coordinate system. Then I am going to calculate area of the triangle formed by the line with this x-axis and with the y-axis. For suppose if this is the line, see, this is x intercept of the line and this is y intercept of the line. You may say if it may be in the negative direction of x or it may be in the negative direction of y, right? See, if this is x intercept and this is y intercept, then its area, it looks like in the form of a right angle triangle, its area is half x intercept into y intercept. The values of x intercept and y intercept may be positive or may be negative according to the position of the line. So we are considering the area of the triangle as half mod x intercept into y intercept. So area of the triangle formed by a line with the coordinate axis is nothing but half mod x intercept into y intercept, right? For suppose if you have a triangle of the form ax plus by plus c is equals to 0. What is its x intercept and y intercept? To find out the x intercept, you just replace y with 0. On x axis, y value is 0. If you replace y with 0, then you will get x as minus c by a. So for this, the x intercept is given as minus c by a, whereas y intercept is mentioned as minus c by b. So if this line is ax plus by plus c is equals to 0, then the area of the triangle is given by half mod x intercept is minus c by a, whereas y intercept is minus c by b, and on calculation you have it as c square divided by 2 mod ab. So in generally we say that area of the triangle formed by the line with the coordinate axis as half mod x intercept into y intercept. In particular, if the line is ax plus by plus c is equals to 0, then we say that area is c square divided by 2 mod AB. And according to the line, we will calculate the area of the triangle. For suppose, if the line is in intercept form, then the area of the triangle is directly half mod AB. I think you know that intercept form of the line is x by a plus y by b is equals to 1. For this line, this a is x intercept, whereas b is y intercept. Then if this line makes a triangle with the coordinate axis, then its area is given by half AB, directly half x intercept into y intercept. The basic thing is half mod x intercept into y intercept, and according to the equation of line, we will find x intercept and y intercept, and afterwards we will calculate the area of the triangle. And we have different types of problems. For suppose they may ask you to find the area of the figure formed by the lines a mod x plus b mod y plus c is equals to 0. See, to find out the area of the triangle formed by these equations, see, this is mod x and this is mod y. So x may be positive or may be negative, y may be positive and y may be negative. Then this modulus equation will represent four different lines, that in the sense a plus or minus x plus b plus or minus y plus c is equals to 0. We have different options, both plus signs, both minus signs, one plus and one minus sign, here plus and there minus sign. So totally it represents four lines. So if you try to draw a figure related to all these four lines in the coordinate plane, it looks like this. If this is the coordinate system, if one of the line is ax plus by plus c is equals to 0, both plus signs, then another line will be on this format and one more line will be like this and another line is like this. Totally you will get a rhombus like this. And already I mentioned you that this area of the triangle formed by the line with coordinate axis as c square by 2 mod AB. And now here we have four such triangles, then the total area is 4 times that value, it represents 2c square by mod AB. Once again, just verify it. Area of the triangle formed by this line with coordinate axis is c square by 2 mod AB. Area of the triangle formed by this with the coordinate axis is 2c square by mod AB. And we have one more frequently faced situation related to this area. For example, in the coordinate system, this is the coordinate system. You may say it as y-axis and you just take it as x-axis. I have a point somewhere h comma k here, and if you observe, there exists many lines passing to this point intersecting the coordinate axis. See, there are so many lines passing through this point intersecting the coordinate axis. I mentioned you just two, you may draw many. Among all those triangles, the minimum possible area of the triangle is 2hk. The minimum possible area of the triangle is 2hk. This is what you have to remember, right? This is a problem actually, but I am mentioning it as a logic, right? So there exist many triangles passing, many lines passing to the point h comma k. All those lines will form a triangle with the coordinate axis, and automatically they will form triangles. Among all those triangles, the triangle having the minimum area is 2hk, right? This is the fourth conceptual idea. If you observe it, then I will move for the fifth conceptual idea. Have a look here. See, the fifth conceptual idea is about the distances. See, I have a point p x1 y1. Distance from the point p x1 y1 to the line ax plus by plus c is equals to 0 is given by the rule that modulus of ax1 plus by1 plus c divided by root of a square plus b square. If we have a line and a point, for suppose if this is the line and somewhere you have the point, then the distance from this point to the line is the perpendicular distance, and this distance is calculated using this formula that modulus of ax1 plus by1 plus c by root of a square plus b square. If the point is origin, that in the sense if the point is origin 0 comma 0, you need to replace x1 and y1 with 0 and 0. Then directly you will get that formula as modulus of c divided by root of a square plus b square. Just observe it. If the point is x1 y1 and the line is ax plus by plus c is equals to 0, that is the distance. And if the point is origin, this is the distance. And I have one more thing. Distance of the point along the line having inclination theta. First suppose I am going to explain the situation here. First suppose I have a line here. This line is actually ax plus by plus c is equals to 0. And I have a point P here, x1 comma y1. If the perpendicular distance from this point to the line is given by this formula, but I need the distance along a line having inclination theta. First suppose if this is the line having inclination theta, I need this particular distance, not this perpendicular distance. I need the distance along this line having inclination theta, and that is given by the rule that, right, modulus of ax1 plus by1 plus c divided by a cos theta plus b sin theta. If theta is the inclination of the line, then that distance is mod ax1 plus by1 plus c by a cos theta plus b sin theta. This is also one of the important thing. You need to memorize it, that the distance from the point px1 y1 to the line ax plus by plus c is equals to 0 along a line having inclination theta is ax1 plus by1 plus c by a cos theta plus b sin theta. Related to the distance from a point to the line, all these are about the distances from point to the lines. Related to this, we have three different formulas. Along with this, I have one more thing, that distance between the parallel lines. See, if you observe the lines, ax plus by plus c1 is equals to 0 is one line, and ax plus by plus c2 is equals to 0 is the another line. Then what is the distance between these two? The distance between these two is nothing but modulus of c2 minus c1 divided by square root of a square plus b square is the distance between these two parallel lines. Now, this is the fifth conceptual idea from the straight lines regarding our mains examination. Have a look, and I will come with the sixth conceptual idea. Yeah, now this is the sixth conceptual idea. four different lines are given here, and we need to identify the type of parallelogram formed with these four lines. If you observe the lines, clearly the first two lines, x coefficient is a1 whereas y coefficient is b1. There is a difference only in the constant term, that is c1 and c2. And if you observe the next two lines, x coefficient and y coefficient are same, and there is a difference between only the constant term, that is d1 and d2. Since the x and y coefficients are same, clearly these two are parallel as well as these two are also parallel. Since these two are parallel, so they appear like this, and since these two are parallel and they are like this, so totally these four lines will form a parallelogram. That was clear, right? Since they form a parallelogram, now we need to identify which type of parallelogram it is. We have different types of parallelograms. What are those? There may be a parallelogram, rectangle, square and rhombus. So now we need to identify the type of parallelogram. To identify the type of parallelogram, first of all, you need to find the distance between those parallel lines. Find the distance between these two lines as some P1 is equals to modulus of C2 minus C1 divided by root of A1 square plus B1 square. And then you just try to find the distance between these two as P2 is equals to modulus of D2 minus D1 by root of A2 square plus B2 square. Now you just think about the distances between those two parallel lines. If the distances are same, right? If the distances are same, then there may be a square or rhombus. And now we need to think about these distances, right? What I am going to tell you is, if that P1 is equals to P2 is one case and P1 is not equals to P2 is another case. If P1 is equals to P2, then the possibilities are either square or rhombus. If P1 is not equals to P2, then the possibilities are either it is a parallelogram or rectangle. To confirm whether it is a square or rhombus, we need to think that whether the adjacent sides are perpendicular or not. Then in the sense these two works like adjacent sides. If these two are perpendicular, it is a square, and somewhere there it is a rectangle. So whenever these two are perpendicular, if the product of their slopes is -1, if you apply that one, you will get that a1 a2 plus b1 b2 is 0. Now from there you need to check about a1 a2 plus b1 b2. If this value is equals to 0, then it is a square. If this value not equals to 0, then it is a rhombus. Like this, here also you need to check that a1 a2 plus b1 b2. Now if this is equals to 0, then what it happens? If that is 0, then it is a rectangle. If this is not equals to 0, then it is a parallelogram. So finally, we have four lines, that a1x plus b1y plus c1, a1x plus b1y plus c2, and similarly a2x plus b2y plus d1, a2x plus b2y plus d2. Distance between these two and distance between these two. Observe the values p1 and p2. If they are equal, they may be a square or rhombus. If they are not equal, parallelogram or rectangle. To decide which one is that one, either square or rhombus, for that you need to observe the value a1 a2 plus b1 b2. If it is 0, square, not equals to 0, rhombus. If it is 0, rectangle, not equals to 0, parallelogram. And finally, this is the sixth conceptual idea, identification of the parallelogram. Have a look and I will come with the seventh idea.